Okay, so I have a few more log equations here. So this one, it's log equals log, so I just equate the arguments, but I'm going to get a um, quadratic equation this time. So I'm going to solve that by factoring. So it's going to be minus 32, and I need to add 2r. So I get r squared plus 4r minus 32 equals 0. Need two numbers that multiply to be negative 32 and add up to 4. Be r plus 8. So r is going to be equal to negative 8 or 4. If you put both of those into the original equations, you don't end up with a negative number. So both of them are valid solutions. Okay, this is an exponential one, so I need to get the 2 over to the other side. So that gives me that. Then I need to do log and log base 10. So I end up with negative 7p equals log base 10 of 35. Yeah. Okay, then lastly, I just divide by negative 7. So I end up with p equals log base 10 of 35 divided by negative 7. Okay, this is log equals a number, so I need to condense first. In any of these equations, you always condense before you do anything else, if you can. So this is going to be 3x squared over 3 equals 4. So, okay, so that means I get my equation is really, now I'm ready to rewrite in exponential form. It's 5 to the 4th power is equal to 3x squared over 3. And note the 3's cross out, so I just get x squared equals 5 to the 4th. 5 to the 4th is actually 25 times 25. It is a perfect square. So when I do that, I get x equals plus or minus 25. And if I put those back into the original equation, I don't have any problems because I get positive values for the arguments of the logs. All right, moving on. Is that 47? Oh, no, there was another one. Okay, so I'm going to condense. And then I rewrite in exponential form. So 2 to the 1st power is equal to 5x squared. All right, then I'm going to divide by 5. And then I'm going to take the square. So now I'm up to x squared. Yeah, x squared equals 2/5. So I take the square root of both sides to solve. And I end up with x squared, or x I should say, excuse me, plus or minus square root of 2/5. Almost done. Okay, this is an exponential one, so before I do anything else, I need to get the term with the exponent all by itself. So I have 8 to the n plus 10 equals 72 over 5. Okay, now I'm going to do log base 8 of both sides. I cause that to cross out. I get n plus 10 equals 72 fifths. I'm going to subtract 10 from both sides. I get n equals, let's see, so negative 10 is going to be negative 50 fifths. So 72 fifths minus 10 is the same thing as 72 fifths minus 50 fifths. And 72 minus 50 is 22. So that means n equals, let's see, 22 over 5. And that would be it. Okay, then finally a little bit of trigonometry here. Okay, so what's the sine? The sine of theta is the opposite over the hypotenuse. It's this O in SOHCAHTOA. So that means you're not asked to solve for anything. You're just saying sine theta equals 9 over 15. And that would be your answer. All right, I think I just have one or two more problems here. So let's plug through it and see if we can finish this up. Do I just have 50? No, I have 51. Okay, so 50, find the nearest measure to the tenth of the measure each side indicated. Okay, so I need to use the 31, I need to use the 6, and I need to use the x. Relative to 31 degrees, x is in the opposite position, 6 is in the adjacent position. So that means I would use tangent. All right, that's the OA in SOHCAHTOA. So I'm going to do sine 31 degrees equals tangent 31 degrees. My mind's on other things. You guys must think I'm losing it. Tangent 31 degrees equals 6 divided by x. Then I need to solve that, so I'm going to multiply both sides by x. So that gives me x tangent 31 degrees equals 6. And then divide by tangent 31. When I don't blow this up, I get really messy. Okay, so I get x equals 6 over tangent 31 degrees, whatever that is. Okay, and then could it be the last one? Yes, it is. Yay! Okay, this one I'm trying to find angle theta. Okay, relative to theta, 4 is the opposite, 9 is the adjacent. So I'm going to use tangent again, and I'm going to say tangent of theta equals 4 over 9. So now the way to solve that is to do the inverse tan of both sides. Causes that to drop out. We get theta equals inverse tan 4 over 9. And that's it. All right, that's it for these screencasts. Hope someone watches them. It did take me quite some time to make them, so I hope you take advantage of them. Cheers.